See Lindelof videos. Solve logarithmic functions which include ln of x. So we have this problem to solve here. We have ln of 2 minus ln of 3x plus 1 is equal to 1. What you really have to do is make sure you've memorized all your properties of logarithms. And one of the properties says this, that if we have like bases and we see a negative sign, it tells us we need to divide. So we can, it's called condensing. We can condense this as 2 over, this negative sign gives me this division sign, 3x plus 1 is equal to 1. One of the big secrets about solving logarithmic functions is to ask yourself, do you have a logarithmic function on both sides? If you do, that can be really good news. If not, it's usually best to exponentiate. So this is another fact that you have to kind of keep in mind, that ln of x is exactly the same, or can be rewritten as log base e of x. And remember that e is an exact number that's quantifiable like pi. It's 2.71 and change, but the best way to represent e is by calling it e. So I'm just going to rewrite this so you can see it, so you can see what I'm doing here. I'm saying that ln is log base e. The rest of it I'm going to keep the same. 2 over 3x plus 1 is equal to 1. The reason I did this is because I'm going to exponentiate. And to exponentiate a function is to take it out of its logarithmic form and to put it into its equivalent exponential form. So, and look at this for a second. So if I took like this, if I had log base 5 of 25 is equal to 2, I could rewrite this. I could exponentiate this and say that this is 5 squared is equal to 25. So exponentiated, this would be 5 squared is equal to 25. And that's my intention here on this part of the problem. So that's what I'm going to do here. So I'm going to end up with, I always say follow the yellow brick road, and that's what you're going to do. Just follow the road, goes to here, and then is set equal to this. So we're going to end up with e to the first power. This e is this 1 is the power that it's equal to, isn't it? Is equal to 2 over 3x plus 1. This gets to be a little bit weird looking because people can't figure out, like, am I solving for e or am I solving for x? E is a number. It's Euler's number. He came up with this equation, 1 plus 1 over x, whole thing to the power of x, and said if you set that equal to a really big number, you get this number back. So this is Euler's number here. So all I'm going to do here is cross multiply. So I'm going to cross multiply to here. I get 2 is equal to e times 3x plus 1. Now, this just turns into some weird algebra. It's not difficult. The bothersome part is that this e is going to bother you. So all I'm going to do is distribute this to here and to here. And 3 times e times 3x is 3ex. The reason I put it this way is because 3 is a number, and e is a number, and x is the variable. And e times 3 times, oh, this was supposed to be a 2 here when I did the problem that I set up. No, it'll work just fine. All right, so plus e is equal to 2. Now all I'm going to do is, remember, I'm doing algebra, and my goal is to get x by itself. So I'm just going to start subtracting stuff. I'm going to subtract e from both sides, and I'm going to get 2 minus e is equal to 3e to the x, 3ex. Remember, again, we want x by itself, and 3e is being multiplied by it, so I'm going to divide everything by 3e, and we'll get x is equal to 2 minus e over 3e. If you're one of the people that asked me to do this problem, please keep in mind that this was supposed to have been a 2, and I ended up putting it down as a 1. So the answer for your problem will be a little bit different. So thanks for watching. If you have any questions or comments, please let me know. And if you haven't already subscribed, please do.